Hey there, welcome back to Heiko Prints. I know I haven't been posting any videos in a while. I was too busy with too many projects. And one of the little projects was actually this puppy. This is a CTC Bizer from 2015. It's one of the many clones of the original MakerBot Replicator 1. These came in assembly kits. Completely, the body, the frame, so to speak, is completely made out of plywood, and it's all bolted together with nuts and bolts. No big deal. You know, they worked, and a lot of people spent a lot of time getting them running well and printing well and modifying them, and there was so much modifications that are available for this printer. It's almost unbelievable. It was handed to me for free in a big box, wasn't working. They couldn't figure out how to make it work. And so originally I just took it as it was with no modifications, and I just tried to figure out, okay, how did people use this CTC Bizer back in the days? And this actually has a 8-bit controller board here in the bottom, and it has a USB port, and with that USB port and a long USB cable, you could hook it up to your personal computer and then use a software called Replicator G, which is a slicer software, so to speak, but it directly communicates with the control board here in this printer. And I was able to make them talk to each other. Then I had to first figure out how to configure it and really have the right configuration for this printer loaded in Replicator G, because Replicator G was not exclusive to this model, but to many printers of this era. And surprisingly, I got it to print pretty well. It actually originally was a dual extruder head. So you had two extruders here right next to each other, which is kind of a pain in the butt. You have to get them leveled perfectly next to each other. As soon as you change the nozzle on one, you have to redo everything, or else one nozzle will always drag over the other print. And kind of annoying, so that eventually went by the wayside, and I removed one of the two extruders. But yeah, I got it to print and it was working really well. Obviously really slow, you know, 8-bit board and all that. So the entire computing power to make all the proper steps for printing were done on an 8-bit board that uses the Atmega 2560 chip. But it was working. And then I started really figuring out things and modifying things. So if you look at the support for the Z-axis for the print bed, this is all aftermarket. I just recently actually bought that off of eBay. There's still a company, I don't know, they're in Germany or in Switzerland, I forgot, but sorry, it's a little dusty, but this whole billet aluminum contraption here with new bearings was replacing actually a plastic part. And a lot of those printers from this era, they had a problem that eventually, due to constant heat from the heated print bed, the plastic parts that hold up your print bed would deform, and then you would just run out of adjustment rooms for your little bed adjustment knobs here at the bottom. So I replaced that. Originally, it also had some sort of almost like a glass print bed on here, but I got rid of that in favor of just a PEI sheet with a magnetic, you know, little magnetic sticker on here. Works really well. And then, like I said, I did, yeah, let's move you guys around a little bit. Let's look right down into it. So the motion system, as you see here, are on rods with regular bearings, right? Y-axis and the X-axis. And then two extruders here next to each other. One was removed in favor of a modification that someone else came up with. I just printed it, was a parts cooling solution, which is just a normal fan blowing down and blowing right at the nozzle pretty much. So now this thing actually has pretty decent parts cooling capabilities, and PLA printing in this printer is absolutely no problem. Back here you can see a Z-axis limit switch, which is now disconnected in favor of a inductive sensor. This machine here is now fully Klipperized. I have all the features and functions that Klipper offers, including adaptive meshing and purging. And like I said, this conductive or inductive sensor here is now replacing the Z-axis end stop switch. And this is all still possible with the original controller board. So I'm still using the controller board that it came with. And then, believe it or not, even our little screen here in the front and the push buttons still function as advertised. So I can still go into the menu here. I can do control, temperature. Let me get you guys a little closer. You can see what's going on. So anyways, the little screen here is still compatible. The control buttons are still working. A couple other things I have removed since because they're just not needed at all. But this little printer is using a, let's see if I can turn it around here real quick. Let's unplug it for a second. This little printer here is being controlled now by an Innovato Quadra that runs a version of Armbian, which is a Linux operation system. And on this Armbian Linux, you can install Klipper with the Klipper install and update helper script. And here is just a regular USB-A to USB-B type that connects to the printer itself. And let's put it upside down here real quick just so you guys can see what is going on here underneath. This is still the original power supply. As you can see, this is all still original wiring from back in the days. Instead of shortening the wiring, they just looped it all together. I might eventually actually shorten that and update that. This is all here little clamps where you clamp the wires into. I updated some of the wiring. I put some crimped ends onto the wires. I added some Noctua fan here to cool the steppers for the stepper drivers, I should say, the stepper drivers here with little heat sinks and all that. I actually even replaced the stepper drivers themselves to a quieter version, which is now the 2208 stepper driver. They perfectly work with this old ancient 8-bit control board. And yeah, like I said, all the thinking and the computing is now done by this little Innovato Quadra Klipper machine. You could also use a Raspberry Pi or any of the other miniature computers, single board computers that you can buy. It all still works. It is compatible with the screen and with my little touch button control here in the front. And now just to show you that a 10-year-old printer, it's really kind of cool in a way that you can use such an old machine with a little bit of tinkering. Klipper is such a powerful front end, or should I say, it's not an operating system, but yeah, a user interface control software for 3D printing that you can wake up an old machine and really get good printing quality and even reasonable speeds out of it. The Innovato Quadra is, of course, Wi-Fi enabled. So I am able to control it via mainsail or fluid. I usually just use mainsail. Mainsail is the one that I'm more familiar with. And here just to show you what that looks like. So with touch buttons, I just told the machine to home, and the X and the Y axis still use limit switches, which is perfectly fine. I'm pretty sure that with a 2208 stepper drivers, I could probably do the ramming. What is it called? Yeah, by clipperizing this old printer, which really is possible with any old printer. Obviously, I mean, this is 10 years old. It doesn't get much older than that. And since it's clipperized through the Innovato Quadra and the Klipper install and update helper script was able to flash the firmware here right onto this controller board. Now I have all the functionalities that come with Klipper. So I have control over the printer via mainsail. It can do adaptive meshing and purging. It does input shaper, which I have a the vibration sensor or the input shaper sensor that I can hook up to USB. So now it's homing the Z-axis by using the inductive sensor there. And just for funsies, we're going to start a print here real quick. Actually, let's go back to the height map. Let's do calibrate, default. So now it's just going to do a quick mesh of the entire bed. Let's move you guys up a little. There you go. And all those Klipper functionalities are, of course, outside of this old machine. So the controller board is really only taking over the control inputs from Klipper and turning them into control signals to the steppers and whatnot. So the 8-bit board really doesn't have much to do with any of this. This is all Klipper directly. Now you will see that the bed is not the straightest, but due to the meshing capabilities, Klipper can actually compensate for the unevenness of the bed. And then you will still be able to get a pretty decent, look at this here. Here is the bed mesh of this bed, and it looks really horrible. There are only 4 adjustment screws here where I could manipulate the height of the bed or the evenness, so to speak, and that's pretty much all there is. It's terrible. Yeah, so that is one big downside. What I could do, which is probably a good idea, to get a new heating element for the bed and then replace the entire bed with a thicker sheet of aluminum. That would be probably a worthwhile upgrade of this little printer. But yeah, just for funsies, let's start a simple print. So it homes again. The stepper driver upgrade on the control board actually made the printer much quieter. So now we're heating up. Where is it? Where's the temp? Down here. So now we're heating up. It's actually heating pretty quickly, surprisingly. I was also able to do the PID calibration for the extruder temperature and the bed temperature. So fully Klipperized. So pretty much what am I trying to say? I'm saying that even with a really old clapped out printer, you are able to get pretty decent print results and pretty good usability. I mean, this machine is really far away from high tech, but even really old Enders and printers like this, they can still be made usable in 2025 by just Klipperizing them. It's really pretty impressive how this little printer actually cranks out objects. So now it just does an adaptive meshing. My boys have been on and off printing with this little thing. You know, all those little gadgets and toys that you can print. This is just standard PLA. This is not a full metal hot end. It still has a PTFE tube in there, and you definitely don't want to burn that up. Causes toxic gases and all that stuff. So just stick with simple filaments and you will not have any problems. So pretty much any old printer can be Klipperized. If this 8-bit board can be Klipperized, you can make it happen with anything. So the MakerBot Replicator 1 had a lot of clones. There was the FlashForge Creator, the TengiBot, there was a G-Tech Mighty Board Ref G. one Hao duplicator. This is decent print quality for this old machine, and the outcome of this is going to be actually pretty good. I'm not saying this is Bamboo Lab X1C quality, but overall this is really a usable little printer, especially if you want to have a maker space for your kids, or you want to use this for simple projects and gadgets. It's pretty small print volume too, but those printers are available so cheap, and then you just tinker with it a little bit and you learn about 3D printing and you learn about Klipper. This is not bad. This is actually pretty acceptable speed for this old machine. Yeah, there we go. We just printed a calibration cube, which is a pretty small item. And print quality, if you take a quick look at this here, is actually, for a plywood box of a printer, really impressive. And this is only possible due to Klipper. You know, we have pressure advance and input shaper all activated here in use. And this is definitely not a rigid structure and not a very good motion system. And all the steppers are the old ones from 10 years ago. And still, you know, pretty good. And like I said, my kids have been printing here non-stop daily, pretty much. Always like little trinkets. And that stuff actually turns out really well. So yeah, just a little encouragement. If you guys have an old printer lying around somewhere and you haven't used it in a few years because it's so slow and not really good, and you know, print quality is terrible, try to Klipperize it. Get yourself a $20 Innovato Quadra or $30 Raspberry Pi, install Klipper on it, flash the firmware onto the printer, and see what you can do. You know, this thing is really absolutely usable. If you have kids and you want to give them a printer, this is perfect. Stuff like this is perfect. It prints fast enough. It's not going to be part of a print farm for sure, but it actually makes a thing that sits in someone's basement and it's not being used in a few years a proper usable 3D printer for PLA. Don't try to do, you know, ABS and whatnot. If I can find a full metal hot end, I could even pull off that. Pretty good, huh? What do you guys think? You like the upgrades? Let me know if you have any questions. Let me know if I can help you maybe make something like this happen. Just put it down in the comments. Thanks for watching, guys. See you next time. Bye.